Hi Year 7, this is our last lesson for fractions, and in this lesson we're going to learn about applications. So we're nearly there. This is what we've learnt so far. Fraction notation and how to change from improper fractions to mixed numerals and vice versa. How to compare and order fractions. How to multiply and divide fractions. And then last lesson we looked at how to add and subtract fractions. Now, one important application of fractions is being able to express one quantity as a fraction of another. Like this example, Julie scored 48 in her test. The total marks were 60. What fraction did she get right? And we have to write our answer in simplest form. So this question is asking us to write 48 out of 60 as a fraction. Well, that's pretty easy, isn't it? There it is. Now we have to simplify it. When you've got larger denominators and numerators, probably the best first step is to halve the top and the bottom to see what you're working with. Half of 48 is 24 and half of 60 is 30. We can continue to do that if we want and get 12 over to 15 and keep going. But let's have a look for the highest common factor now. What is the highest common factor of 24 and 30? It's 6, isn't it? So 6 into 24 goes 4 times. And 6 into 30 goes 5 times, and there's our answer. It's 4/5. Now there are different ways that question could have been worded. Here's what we asked. What fraction did she get right? We could have also asked, write Julie's score as a fraction of the total. That's the same question. Another word for fraction is proportion. So we could have written, what proportion did she get right? Here's another example. Express $28 as a proportion of $50. That means write it as a fraction. So we're going to do $28 out of $50. We need to reduce it down. Let's halve top and bottom. We get 14 out of 25, and that's actually as simple as it gets. Sometimes we might have to change units, like this question. Express 3 centimeters out of 1 meter as a fraction. All right, so we can make a fraction, 3 centimeters over 1 meter, but we have to get those units the same. And the thing I want to do is change the meters into centimeters. There are 100 centimeters in a meter, so this is the same as 3 centimeters out of 100 centimeters. Now I can get rid of those units, and there's our fraction, 3 100ths. Okay, let's move on to real life problems. A carton contains 2 liters of juice. Dad drinks a quarter, and then Mum drinks 1/5 of the remainder. How much is left? Now, the best way to do this question is to work with the 2 liters of juice being the whole amount. And I'm going to turn it into milliliters because that'll give me more to work with. So our first step is to say, how many milliliters are there in 2 liters? Which is 2,000. Okay, Dad drinks a quarter. So a quarter of 2,000 is 500 mils. Remember, we just halve it, then halve it again. So how much is remaining after Dad has drunk 500 mils? 1,500. So Mum is going to drink 1/5 of 1,500. Now we want to know how many 5s go into 1,500. That's a division question. 5 into 15 goes 3, and so 5 into 1,500 is 300. Now all we have to do is a subtraction. So we're going to do our 1,500 and take away our 300, and we're going to get 1,200 mils remaining, or 1.2 litres. Here's another problem. Liam spent 1.5 hours doing his homework. 3/5 of this time was spent on maths. How much time did he spend doing his maths homework? Key word here is of. In maths, of means times. So we want 3/5 times 1.5. There it is. When we're multiplying fractions, we need them to be written as improper fractions. So let's turn this mixed numeral around. 2 ones are 2 plus 1 is 3. So I want 3/5 times 3/2. Multiply across the top, multiply across the bottom gives us 9/10 of an hour. Now, there is another way to do that question. We could have turned the 1.5 hours into minutes. That would be 90 minutes. And we could work out 3/5 of 90. So what we would do is this division first. 5 into 90. That gives us 18. So 3 times 18 is 54 minutes. And these two answers are the same. It's just that this one's written in hours and this one's written in minutes. Here's a harder problem. Justin's cup is half full. He adds 50 mils to it so that it is now 5/8 full. How much does the cup hold? So let's start with a diagram. So we've got a cup that's half full, and after he's added 50 mils to it, it is 5/8 full. So basically we want to know how much has been added. How much bigger is 5/8 than 1/2? So let's start by converting 1/2 to eighths. That is 4/8. How much bigger is 5/8 than 4/8? It's 1/8, isn't it? Now we're going to write this. 1/8 then is equivalent to 50 mils. That's what this 3 equal sign means. 1/8 is equivalent to 50 mils. So what's the whole? The whole cup must be 8 times 50, which is 400 mils. All right, let's finish off with these. Write a fraction that lies between 1/2 and 1/5. Now we can't do anything with that question whilst it has different denominators. We're going to have to change them to be the same. So let's change them both to tenths. 1/2 is the same as 5/10. 1/5 is the same as 2/10. We need a fraction that lies between them. We could choose 3/10 or 4/10, or we could simplify 4/10 and write it as 2/5. There are other answers to this question, but these are the simplest. How about this one? 4/5 and 3/5. Right, a fraction in between 4/5 and 3/5 is like 3.5/5, but that's not a fraction. What we're going to have to do here is get a bigger denominator so we can split them up. So we're going to turn them both to tenths. So I'm going to do 8/10 and 6/10. What's a fraction that lies between them? 7/10. Last question. What fraction lies halfway between 1/3 and 1/5? Again, we need common denominators, so let's go to 15ths. We're going to have 5/15 and 3/15. A fraction that lies halfway between 3/15 and 5/15 is 4/15. Okay, that's the end of this topic on fractions. Our next topic for number is decimals.